Hello, everyone. My name is Rafael Lima, and today I'll be giving a talk about the improvements that have been made to the solver in Calc. So, to give you a bit of context, last year I was in Bucharest in the conference, and I presented a few, actually, a new feature that was added to the Calc solver, and in this year, I will present some other new features that have been added. So our agenda is this. First, I will discuss about the new support for hidden named ranges. And then I will at least show you a new UNO API that was developed to create solver scripts. And then I will show you the new feature that generates sensitivity reports in Calc. And then I will discuss the integration of another solver engine named Google OR Tools into LibreOffice, which is something that's still a work in progress. So as I was mentioning earlier, last year I fixed a bug that was bug 38948. So it's a very old bug. And it was about saving solver settings to the file, which is something that was missing in Calc. So the user created a model, saved the file, but the model was not saved. And the idea was to use named ranges to save the settings, the solver settings. And why named ranges? Because this is exactly what Excel does. So the solver in Excel uses hidden named ranges to save all the settings of the solver. So I used the same strategy, and this is now available since LibreOffice 7.6. So this is something that the users can already make use of. So what we needed to do after that. So now I'm going to present what was done after what I presented last year. So the first thing I worked on was with hidden named ranges. Why? Because when we open a solver, actually a calc file with a solver model, if we go to the Manage Names dialog, we're going to see a dialog crowded with named ranges. But why does this happen? So this happens because in Excel, they support hidden named ranges, which is something that various extensions developers in Excel, they use this as a way to store information in the file, and the user can't see this. But this was something that was missing in LibreOffice. So I implemented the possibility to create hidden named ranges. So it's a new type of named ranges and also named expressions. Okay, so this is not something that's going to happen anymore when you open a file with solver models in Calc. So all the named ranges used for solver models will be hidden. Also, it's interesting, I'm just showing you here the main tickets that were related to this. So first, I introduced the support for hidden named ranges. Then I introduced support for hidden named expressions, and then I hid the named ranges used for solver models in Calc. So all of these features, the complete feature set, has been available since LibreOffice 24.8. Okay, so this latest release already has all these features. Also, as a reference, I know that some of you like to work with macros. So if you want to hide or unhide named ranges using macros, so this is a macro that shows how this is done. Basically, we have a series of constants in this constant star sheet named range flags. So we can use this hidden flag to apply to a named range. So this will ensure that the named range is not shown in the UI. Now on to the second point, topic of my talk. So another thing that I did in the last year was to introduce a new UNO API to develop solver models in Calc. So why did I do that? What was the purpose? Because we already have, not in Calc, but in LibreOffice, this service, CSS Sheet Solver, which is a service that already exists, and it allows us to create an instance of a solver engine. So why did I feel the need to create another API to create solver models? This is because the existing API does not allow us to create solver models that are saved to the file or that are visible in the solver dialog. Since I have my laptop connected to the screen, let me show you an example. So this is a solver model to the knapsack problem, okay? So if we go to Tools, Solver, so you see here that we have a solver model, okay? So all of the things that I'm going to do now, so this is in the dialog, the solver dialog. So all the things that I'm going to do now weren't previously possible. So first, I'm going to reset this solver model. So I clicked here. So if we check now the dialog, we no longer have a solver model. So this API that interacts with the solver model in the sheet did not exist. So now, if I now create the model, you can see that it is here in the dialog. So I have the script that creates this, and this model will be saved to the file. So we can now automate the generation of solver models. And also, we can now call the model that is associated with this sheet. So if I simply click Run Model, it runs the model, shows us the solution, and we're good to go. So all of these very useful scripting features did not exist, and they were introduced with the new API. Wait a second. With this new API, which is the interface X over settings that was introduced by Dispatch. And also it introduced a few other things, a few structs and constants. But the main API is this. So every sheet now has an object that implements this interface and can be used to create solver models in the sheet. And they will be visible in the dialog. So here is just a small example of how we can use this new API. So it's simple. Here we use this component, sheets get by name, so we get the sheet, and then we get the solver settings object here. So from now on, this is all the new API. So first we can set which solver engine we're going to use. In this case, I'm using LP-Solve. Then we set the objective cell, the type of the objective, which in this example is maximize. Then we create a sequence of, actually a sequence of variable cells. In this example, we just have one. And then we create a sequence of constraints. In this example, we have 2 constraints. And then we save these to the file. In this macro, I could have simply called .solve to execute the solver model. But here, when I say save to the file, it creates all the named ranges required to save the solver model to the file. So, and here also, I'm showing you here just I'm going to leave this as a resource for people in the future who want to create such scripts. So this is the script to run the solver model. So I simply get the solver settings object and then I solve it. And if I want to reset the solver model, I simply get the solver settings object and reset it. So it's the idea was to make all the features that we have in the UI available via scripting. So what's the status of this implementation? So the main implementation is done. All that I had planned feature-wise is working. The patch is merged. It will be available in LibreOffice 25.2. What's still lacking is more CPP tests. So the patch had a very long unit test, but I still think that I need to create more tests for each object, for each method, to ensure that no regressions will be introduced in the future. And thanks to Thomas. Thomas, he just passed here. So Thomas was responsible. Oh, Thomas is here. Sorry, I saw you in the back, and then I was looking, where is Thomas? Thanks, Thomas Weingel, for the review. And now moving on to the third topic of my talk. So one thing that I developed recently is the sensitivity report, which was a missing feature in the Calc solver, which prevented me from using LibreOffice Calc for classes in operations research, because when we are teaching linear models, how the simplex algorithm work, so we need to show them the sensitivity report, which is something that Excel supports. It has supported sensitivity reports since forever, and we were lacking this feature. So this ticket requested the implementation of the sensitivity report, and this is what I did. So first I implemented the LP solve sensitivity report, because for you, if you don't know, LibreOffice has two solver engines for linear models. We have LP solve and CoinP. Both of them are capable of reporting the sensitivity report for us, but we need to implement each of one separately, because there are separate components in LibreOffice. So what I did was simply to create a new struct called CSS Sheet Sensitivity Report. And this struct stores all the sensitivity information while the solver is being run. So LPSolve and CoinP can give this information, but we were not retrieving this information when we were calling it. So now, as we call LPSolve, we retrieve the sensitivity information, we store it in this struct, and then return the struct to the UI so that the report can be shown to the user. So here, let me show you this. So this is the sensitivity report in Excel. So I was trying to follow the same structure. And now this is the sensitivity report in LibreOffice Calc. Okay, so the idea here is that we now have in the options dialog of the solver a new option. So there is this option, generate sensitivity report, so we check it, and as soon as the model is solved, the sensitivity report is shown like this. So as you can see, there is just a cosmetic difference between this report and this report, because all the informations are the same, the values are correct. But I plan to, still for 25.2, implement a subsequent patch to format this table and make it look more beautiful. Because really it feels like too raw text for the user. So I intend to make it look more like this. And what else? So what's the status and the roadmap for this feature? So the LP solve patch is done. Actually, I wrote here that it's under review, but yesterday Mike Kagansky submitted the patch, so I'm glad to tell you that in 25.2 this will be available. So I need to do the same for CoinMP, so this is my next patch. Also, I plan to make the report prettier, so this is something that's in the roadmap as well. And I need to write a few more CPP tests to ensure that we don't get any regressions with this. So thanks to Mike Kagansky for reviewing the patch. And finally, my last topic, I'd like to discuss the integration of Google OR tools into LibreOffice Calc. So first, what's Google OR tools? So it's an optimization suite developed by Google that offers access to various solver engines. So if we integrate OR tools into LibreOffice, we make it available to users various solver engines, such as CBC, which we sort of support via CoinMP, SIP, GLOP, and CPSet. Actually, the main reason why I'm trying to integrate OR tools into Calc is due to the CPSet solver, because it's a constraint programming solver by Google that's really good, and it can solve a variety of problems that we couldn't solve with the existing engines. So this is something that I'm working on integrating. So the idea here is to integrate OR tools via an extension. So I created an extension. So if you go to my GitHub page, you'll be able to download it. It's not in our extensions website yet because it's still alpha software. It's not, it's working fine, it's okay. It doesn't have any major bugs, but still I need to do more testing. I need to do maybe a few refinements, but it's working. So the extension, since it is a Python extension, it requires the installation of the OR tools Python package. So this needs to be accessible in the user's Python path somehow. So in my case, since I'm using Fedora, it's easier to have it installed on my LibreOffice installation because it's using system Python. So if I simply pip install OR tools, it will be available in LibreOffice. But in other operating systems, I created a dialog. So let me show you this. So we can first, this dialog is available in the extension. So we can first test if we are being able to access all the components of OR tools. Currently, I haven't been able to make CPSet work yet. So this is a challenge for, that's why I'm calling this alpha software yet. But here in this dialog, we first test if all of the modules are accessible. We choose which solver engine to use when we call OR tools. And if we define an external virtual environment for Python with OR tools, we can use this button to point to that path so that the user can import OR tools from an external Python path, actually virtual environments. And here is the solver options dialog with the OR tools for linear models selected. So another thing that I'm still planning to develop, because I need to include here more settings for the solver. I just added the basic settings, so just to make it work. So what are the main challenges here? So actually, this is something that happens to other solver models as well, because when we solve something in the sheet, the LibreOffice tries to infer what linear model we're solving. And how is it done? It's done in a very simple way. What it does is for every variable, for every function, it tests what's the value to for 0 and then to 1 and see the difference, and uses this as the coefficient for the linear function. So it's just testing a lot of zeros and ones and seeing the impact on the function. And 99.9% of the time spent by the solver is doing that. If you put timers to see how much time is done, actually the solver itself takes 0.1% of the time to solve. The main time is spent inferring what our linear model is. So this is a challenge because we need to call set value and get value many times, and this is not very efficient. And this is not a problem in my extension. This is a problem in all solver components in Calc. So this is a challenge, okay? And to finalize my presentation, what's the status of the extension and the roadmap? So currently we only support linear models. CPSat is not working, as I said, but as soon as I get CPSat to work, I'm planning to implement quadratic programming and nonlinear programming using piecewise linear functions from the OR tools library, which should give us new possibilities with regards to optimization. Also, I plan to do the same for other commercial solvers, such as Gurobi and Cplex, because these are professional solvers that are used for large-scale problems. And I believe that if LibreOffice can offer support for these solvers, this would be another great selling point for LibreOffice, because this is something that Excel can't support at the moment. So that's it. Thank you for your attention. And now questions. I guess you should speak in the microphone.
So it seems that in your extension, you offer a choice of solving engine that is at the either the calc session scope or maybe the spreadsheet scope. Does it sometimes happen in terms of use cases that in a single spreadsheet you have one problem to solve that would use one model and another maybe on a different sheet that would use another model?
Yeah, well, thanks for the question. So, yeah, this is a limitation. You just spotted the limitation, because if I set, let me show you it working here. So let's pick up a simple model. Let's get this one. Okay, to solver options. Okay, so if we use our tools here, okay, solve, so it works fine. So the problem is this: if we go to tools or tool settings, which is here, so we can test which of them are working. So we get that screenshot that I shared. So yeah, this is a limitation, because here I'm using CBC in this example. So all further models that I call using our tools will be using CBC. If I need to solve a different model but with a different engine, I need to come here and manually change this to, for instance, let's use GLOP, or SCIP is better in this case. So now it's using SCIP. But if I need to solve a different sheet with a different engine, I will have to manually change it. So yeah, I agree with you that it would be nice to sort of remember this setting. Is this what you were sort of proposing? Yes?
I was just wondering if in practice when people use solvers, I was wondering if in practice when people use solvers, do they typically use the same solver all over, or do they like pick and choose for different problems? It's more of a use case question.
Well, actually, when you are working with nonlinear models, you need to choose a nonlinear solver. And for linear models, you need to go to a different solver. So since all the solvers that I showed here are for linear models, changing the engine is not very important. So in the future, when I implement, for example, the quadratic programming optimization solver, so this will be a different entry in the solver options dialog. So when the user chooses the quadratic solver instead of the linear solver here, so it will be saved. Okay, but you're right. Different solvers for different problems, and this might happen in the same file.